So ladies and gentlemen, boys and girls, children of all ages, we are going to go over the two multiplication problems we did yesterday, where you had an assignment. You could not do them again, which some of you didn't read that part, which I do want to point out. I have something written on the sideboard. Is what I do is I take letters and I put those letters together to make words. Then I take those words together to make sentences. And those sentences pass on the information that you need. So when all those people that came up and asked me to reset it, after I spent hours writing down the letters, putting those letters into words, putting those words into sentences, particularly one sentence that said, yeah, you can only do this once, I won't reset it. And then we get a cattywampus answer and it makes Mr. McMurdo sad. Okay? And the same thing on the posts. When I post on Google Classroom and you go, I've done everything, and I'm like, have you done this? No. Well, I use those, again, the letters to make words, to make sentences. And if you read them in order, I read, when I'm reading a book, I like to read from top to bottom. And that way it tells me the story in order. If you read from another direction, it's not going to be a story in order, which will be completely confusing to you. So please, for the love of Pete, read the instructions. So I don't have to, because you come up to me and go, I'm done. What do I do next? What does Google Classroom say? Oh, okay, sorry. Never mind. All right, so we're going to look at these two problems. Stop writing. Pencils down. Pencils down. Now the steps that we need to take when we're multiplying, 97% of you ignore step one. You don't know that. You weren't watching me yesterday. Well, I do know that because the second problem, when we do this, is going to have a significantly bigger answer than what the estimate would be. And so some of you had an answer, 6,000, whatever. Well, that doesn't make any sense. If you'd have estimated, you'd have seen that that doesn't make sense. Thomas Paine! I'm supposed to say that when somebody says common sense. But anyway, I digress. First step is estimate. So I'm going to go through this. I'm not going to ask for help. I'm going to show you again how I talk to myself when I'm going through problems so that when you're doing it, you can model that in your own head how you've learned this. I'm modeling my estimation. I'm going to make this 120 times 50. Why? Because I can do 120 times 50 in my head because I know what 5 times 12 is. I know I'm going to have the two trailing zeros, my ones places, because if I work that out regularly, I'm going to have zeros in the ones place and the tens place. I know that 5 times 12 is 60. So my answer needs to be somewhere around 6,000. It's not going to be exactly 6,000, but it's also not going to be 60,000. It's also not going to be 278. Estimating is important. Most of y'all skip it. I don't want to take that time. I just want to get this done. It's not a race. It's an accuracy contest. Think of it like archery. You want to hit the target. You want to get close to the center as you can. You don't just want to. I shot 97 of them as fast as I could. Yes, sir. All right, so our estimate is around 6,000. The next step is solve using any strategy. Solve using any strategy. I could use the standard algorithm. I could use the array, or I don't know, I've seen it with 100 different names. 100, because the one's in the hundreds place. 20, because the 2 is in the tens place. The value of the 2 is 20. The value of the 1, because it's in the hundreds place, is 100. If I had 100, and then I had 20, 2 tens, and then I'd have to have 3 ones. Every one of you should be able to take a number, especially a whole number, and put it in an expanded form. You've done that. My others, now I have 40 in expanded form and 5 in expanded form. Then, I can do 4 times 3, 4 times 2, 4 times 1, 5 times 3, 5 times 2, 5 times 1. Thank you. I can do all that in my head. So this is going to be 120. This is going to be 15. This is going to be 80 or 800. This is going to be 100. This is going to be 500. And this is going to be 4,000. Y'all can do that. There's zero reason for missing this problem, because then I just add what I have in each of these boxes. None of this adding, no place value adding is difficult. So even if you can't do the standard algorithm, you should be able to do that. There's a lattice method, which I've seen used by many of you. Use that. Okay? The standard algorithm, 5 times 3 is 15. 5 times 2 is 10, plus 1 is 11. 5, 6, 0, 12, 8, 9, 4, 5, 3, 15, 5,535. Is that right?
Yes, sir.
All right, well, let's check to make sure. We get, let's see, that's a 5, 3, 8, 9, 10, 15. 4 and 1 is 5.
Yep.
Okay, 5,335. I've done step 2, solve using any strategy. Step 3, which those of you that don't do step 1 can't do step 3. So you're skipping 2 of the 3 steps already. And is your answer near your estimate? Yes. My answer is not 55. My answer is not 50,000. So it's close to my estimate, so that is reasonable. Check your work. I checked my work. I did it twice. We shouldn't be missing multiplication problems. We shouldn't be missing the multiplication problems. 2-digit by 2-digit, folks. Or 2-digit by 3-digit. That's all you're doing this year. 2-digit by 3-digit. Which means next year if you get 4-digit by 3-digit, it doesn't change anything. It's still just as easy. But I have to have 3-digit by 2-digit, and I'm going to do it 1,000,000 times this year until I know when I send you upstairs, you're like, okay, cool, got this. Easy peasy, raw chicken squeezy. Subscribe or I'm going to cry.